Hello, everyone. My name is Jarek Wilkiewicz, and I work for YouTube. I'm a developer advocate. I have Greg Schechter and Jeffrey Posnick here with me today. And we'll talk about YouTube Iframe player and the future of embedding. So thank you very much for coming. Here's an agenda for today. We will talk about what the iframe player is and why we introduced it, really what is the problem that we're trying to solve. Greg will cover HTML5 video playback, some of the challenges that he has faced implementing the player, as well as the actual API design and implementation. So if you're thinking about introducing your own JavaScript-based API on top of an iframe, he'll highlight some design choices that you might consider in your own designs. We'll talk a little bit more about what are the differences between the iframe JavaScript API that we expose now and the existing ActionScript 3 JavaScript API, and what this means to application developers. And then finally, Jeff created a very nice sample player application for this occasion, and he'll walk you through the implementation of his HTML5-based video player so that you could reuse that code in your own applications. Before we start, if you would like to live tweet about this session, here are the hashtags, IO2011 YouTube. And then we would like you to submit some feedback for us. The QR code is right here and the short link as well on this page. So, this is the summary of the session, really. What are we trying to do is to let the embed, not the embedder, figure out the complexity of web video. So as you all know, what we're facing is really a platform fragmentation problem right now. There's a lot new platforms, new operating systems coming online, especially in the mobile space. So then, in order to provide platform-independent, portable video playback, the embedder actually is facing quite a few choices, and we're trying to simplify this complexity. So, as I mentioned, both we see new platforms. The encoding standards supported by these platforms also vary. So we have H263, 264, WebM, VP8, and so forth. And then the actual embed technology also is different depending on the platform. So historically, we had AS2. There's some RTSP streaming support for feature phones that we still have, AS3, HTML5. So all that actually adds complexity whenever one wants to include video in a web page, or web application, or native application. So the problem that we're trying to solve here is to really provide a simple embed that will work across all the range of platforms and hopefully future-proof the embed. So once you embed a video in your application once, as new platforms come online, we'll take the responsibility of making sure that the video playback is really designed for that platform, works well, and you don't get a black box saying you need to install this or that plugin and so forth. And the lower left, I have a syntax example of the iframe player. So for those of you that have used it before, it should be pretty familiar. For those of you that haven't, one thing to note is there's nothing here about the underlying video implementation technology. So just by putting that snippet of code in your web application, web page, whatever, the only thing it instructs us to do is to actually choose the optimal video playback technology for your device with the encoding that your device can actually support and play the video back. So you really don't have to worry about the complexity. So next, we'll talk a little bit more about the design decisions that drove the iframe player implementation, as well as how we ended up exposing the player API to application developer, much like what we have done with the Flash player in the past. So now I will hand it off to Greg, who dig into the details.
Thanks, Jarek. So I'm Greg Schechter. I'm one of the engineers that works on the HTML5 player and the iframe embed. And HTML5, it's new, it's awesome. You've been seeing all these cool demos. But Flash has sort of been in the business for quite some time. So we kind of wondered, why should we build this HTML5 player? We got this great Flash one. What makes HTML5 better? And so we took a look at both platforms, and we looked at performance, accessibility, something I call deviceability, and all sorts of things, and try to compare the two platforms. So the first thing we sort of looked at is the different features. What does Flash provide, and what does HTML5 have as well? So one of the first things that's really important that Flash has was robust video streaming. In order to provide this really great, excellent user experience, we need to have fine control over buffering and being able to change the quality. We also want to be able to jump to any part in the video when the user is seeking, and HTML5 doesn't quite have this fine-tuning yet. Another important thing is content protection. We don't own all of our content. You might have heard that we just launched all these great video rentals, and we got to make sure that our content's secure. And so Flash has a protocol for this, RTMPE, that's like built in, easy to do, and HTML5 doesn't have an accepted standard for this yet. After that, there's sort of full screen. When I'm watching my favorite cat videos, one thing that's really important is I want them full screen and in HD. And we don't really have an API to do this yet. WebKit does have something in its nightlies, and the code for that's actually pretty simple. It works pretty well. So it looks a little bit like this. You can grab any element. So in our case, we'd grab our video player, and we would request that it goes to full screen. And then once it gets triggered, we can do whatever we want with it, make it larger, change our buttons, and so forth. And so eventually, because this is in WebKit, this will be available in Chrome, hopefully very soon. Another thing that's important is camera and microphone access. A lot of our users come to YouTube and they just want to film talking to the millions of viewers right there. And HTML5 doesn't have this yet, but Flash, it's there. Another interesting thing is formats. So with Flash, it's pretty much going to, if the device supports Flash, you can play your Flash videos without any issues. HTML5, we actually have to support two different formats. We have H.264 and WebM. And so browsers, some browsers will support both. At the moment, Chrome will support both, but then you get browsers like Firefox, which will only support WebM, and IE, which will only support H.264. Now, we have all of our videos are encoded in H.264, and most of them are in WebM at the moment, but it's taken a while because it's such a large database to get through and make all these additional encodings. So now, why is HTML5 so great? And we've got this open source technology, open source browsers, players, and codecs, which really allows for some great development in the space and making it really fast-paced and changing really quickly. It also should have lower latency when we're watching these videos. We don't have to start up this plugin. It's just native in the browser. It should be a lot faster. And this is really evident in the iframe, which I'll show later. And so we're hoping for better performance with these different encodings. We're hoping to get better performance for the videos, and just fidelity, it works smoother without worrying about our code screwing up the video playback. Another great thing is accessibility. And there's a few other accessibility talks here that go into some really detailed stuff here. One of the talks that happened earlier, which was great, was all about captions. And I really like having captions on my cat videos. And this is one of my favorite comic strips there. But one of the features that's important to me is actually navigating in the browser. And because it's native, I can just tab around in the page. So let me show you a quick demo. So this is this is YouTube, and I got the Flash player here, and I start tabbing around the page, and eventually I'm trying to get into the player, but I just sort of jump below it, and my tab focus is down here at the moment, and I can't get into the player. But if I click my mouse in it, I'll give focus to the player, and then I can tab around and use the controls, but I'm trapped. I can't get outside. I can't start to interact with the rest of the page again. One of the great things that's great about HTML5 is I can tab around on the page, and then I can jump right into the player, and I can use my keyboard to start playing the video. And then if I want to move on to the rest of the page, I can just continue to tab around, and I'm out interacting with the page again. And so different user agents are going to have to build APIs for having this special video handling for the video tag, but then screen readers, any screen reader you have, will be able to access that, and you'll have accessible videos. So next thing I want to talk about is deviceability, and that's basically what I mean by that is where do these platforms live? Where can you watch Flash videos, and where can you watch HTML5 videos? And at the moment, when we look at our HTML5 capable browsers, we've got just under 40% of browser usage is HTML5 capable. Chrome is really kicking butt in this space as well. And a very small percentage of this is mobile. So the world kind of looks like this. There's all these places that support Flash, a good chunk that also support HTML5, and this tiny sliver, and this is exaggerated a little bit, that only do HTML5. And that's mostly iPhone and iPad. There's a few other random things that are in there as well. But then what's really interesting is when we look at actual usage of people who are getting access to our APIs, their YouTube APIs, and where they're playing videos, it's actually kind of shifts opposite. Most of the places are actually on devices that don't have Flash. So that's like, really great that we need this HTML5 support there. So we were asking why HTML5, but it's really about when we should be using HTML5, because we clearly see that it's needed in many places. So our first primary goal about building this player was we wanted to recover playbacks that would have been lost without Flash. And so our solution for this, to make it really easy, was to have this iframe embed. So, like we showed earlier, the code for it's very simple. You just plop in the video ID, and you're good to go without having to worry about anything. And so this has, great advantages because it gives our user HTML5 or Flash based on the device and the user's preferences. It allows for so much better mobile support, and it gives us this just works experience. So just a little bit about how you would get the HTML5 player. At the moment, you can opt in to getting the player, and that's if you go to youtube.com/HTML5, you can join the experiment. And if you're trying to view these videos on a device that doesn't support Flash, you'll also be opted in automatically. And so first thing we do is we check, all right, does your browser support HTML5? And the code for that's pretty simple. We just create a video tag, and we see, can we play the two formats I mentioned? So the first one is H.264, and the second one's WebM. Now, not a lot of our embeds actually get clicked onto play, so we don't load all the data about the video yet. So we don't know if we have both formats when we load the video. So that's why we have to check both at the start. After that, we wait for the user to click play. We fetch this information, and then we say, all right, are there any business reasons that we can't play the video, the details which are not all that important, but if it's great, if we can play this video, then we're going to look and we see, do we have a format that's available that this browser can play? And if yes, great, we're winning. Otherwise, we're going to fall back. We're going to go to that Flash player, or we're going to fail out if your device doesn't support it. So the next thing, once we have these two players, we can look at performance between the two. And so the first and pretty much one of the most important things is the player start time. And this is the time just so that it looks like the player's happening. Maybe you, like on the main page, you see like the little loading icon, or it's a time to see the thumbnail on the iframe embed. And so it's the first cue that the user has that something's working, something's interacting. And at the moment, we can see HTML5 is just a lot faster. It's a full half a second faster, which is great. And so I pulled out like this little strip line thing that's got all these photos. And this was in a controlled environment, and the times got exaggerated a little bit. But the comparison is pretty accurate about how much faster the HTML5 player is, just to show that initial thumbnail. And so I want to show you it in action now. So I've got the two players here. The top one's the Flash player, and the bottom one's the HTML5 player. And when I reload the page, we can see that the HTML5 player comes in a lot faster, which is great. And then when I actually go to play the video, sometimes...
Hi, everyone. My name is Steve Chen. I'm one of the co-founders of YouTube, and I run the engineering team here.
Hi, my name is Jeff Stearns.
I don't know what's going on with the Flash player today, but that's another reason I like the HTML5 player more. But you could see that the HTML5 player started a little bit faster, and I actually think that I just got lucky there, because a lot of times the Flash player will start first. So we're still sort of tweaking performance on our end. One of the advantages that the Flash player has is because all the formats are the same, it sort of can take advantage of caching those formats a little bit better. So the next thing is that I want to talk about is the details of our new JavaScript API and how you control the player. And so since we have this new way to embed videos, this iframe embed, we had to write a new API to interact with it. So the most important thing was about communication. We don't have this object we didn't have an object in the DOM anymore that we could just like add things to directly. So we had to think of a way that this API could communicate with the player in this iframe. So the first thing we thought of was to pull the URL fragment. So that's just a little fragment at the end of the URL, and you can update it. It won't cause the page to refresh. And there were a couple problems with this. The messages are very one-dimensional, so it's hard to send complex messages. Polling is going to eat up your CPU, and it's not going to be instantaneous because you're going to have to set a timer, and then you have like different timers conflicting, and it's just a little bit of a hassle to manage. And then the really difficult part is since both directions of communication, sending messages to the player and the player sending messages back out to the page, have to use the same fragment. And so then you run into issues, all right, am I reading data, am I writing data, am I overwriting data I haven't read, and it just gets very complicated. So instead, we decided to use the post message API. Now this isn't available in as many browsers as just being able to pull that fragment, but it works a lot simpler, and then the majority of our users will be able to use post message to communicate with the player. So it's very simple. Basically, you have a window, you just send a message, and you specify the target of your message. And so we basically can use JSON to encode and decode our messages, so it's very native into the browser. We don't have polling anymore, so we can use the native event listeners to communicate. And the communication is sandboxed per window, so they're using different channels, but now all the messages are being sent to the parent window. So if you have multiple players on the page, that gets a little complicated, but we were able to easily differentiate between the different iframes on the page. And one interesting thing is the calls are now asynchronous. So if you wanted to read data from the player, you might have to wait some time. So instead, we just store the player state for you. And so when you interact with the player, you'll get that data that you want right away. So now I'm going to hand it back over to Jarek, who will talk about comparing the iframe API to the AS3 player API.
Thanks, Greg. So Greg went through the design decisions that went into the API implementation, and I wanted to talk a little bit about what this means for an application developer that is used to interacting with our player API in the AS3 world, and what the differences are, how you can take advantage of the new API, and what other things to watch out for. And then to prove that it is in fact possible to use the API and create very interesting experiences around YouTube video playback, Jeff is going to follow up with his example after my part. So for those of you that have worked with the player API, this is very straightforward, but I just wanted to refresh your memory. So there are 3 ways in which YouTube video playback can be controlled by an application developer through player parameters, ActionScript API, and JavaScript API. So let's walk through the 3 mechanisms and see how they differ if you are interacting with the Flash versus HTML5 player. So when it comes to player parameters, there's really 2 cases. One is the underlying video implementation is based on Flash, and again, the decision that drives this is something that Greg has described before. So he had this nice decision tree that was deciding whether to start HTML5 video playback versus Flash playback. So if it's actually Flash playback, then all the player parameters that you are used to taking advantage of, it's just passed through. So they work just like before. And here's an example of a player parameter. This one will trigger the video to start playback as soon as somebody navigates onto a page where the embed is present. If the underlying implementation is based on HTML5 video, then we're subject to some of the limitations that Greg has described, as well as some of the features that we haven't, frankly, implemented quite yet. So here's an overview of things that fall into these 2 categories. I'll just walk through them quickly. One thing to watch out for on iOS is the autoplay player parameter is not really honored. So if somebody embeds a video and then an iOS device navigates to it, then the user actually has to confirm the playback selection. And I guess this is to protect somebody's data plan from getting taxed, even though the application developer would like the video to start playing right away. iOS will not let that happen until the user selects play. Caption support, our HTML5 player does display captions, but there's some categories that we haven't implemented yet. For example, the ASR captions are not shown yet, but this is something that is under active implementation. Full screen support is not quite there yet. The limiting factor here is the browser standardization, and Greg mentioned the work that is done for WebKit to make that available, and hopefully we'll see that across the board, but don't count on it yet. Annotations, another very popular YouTube feature, is not implemented by the HTML5 player. I expect Greg to start doing that as soon as he gets back to his office after this session, because it's a very popular feature. People have done amazing work with it. And then finally, related videos. If you watch a YouTube video, at the end of the playback, you see a bunch of videos that we think are of interest to you. That functionality can be disabled through the REL parameter. That is something we don't have in HTML5 player yet. So next, let's talk about the ActionScript API. So for those of you that have built custom Flash players, what typically people do is we actually offer a Chromeless player that is based on AS3. That player has an API that can then be used in a Flash application. And then you can build your own experience around the core YouTube video playback experience. So if you don't like the way our controls look, any kind of aspect of the user experience, you have full control over that and just invoke API methods. So for the purpose of this talk, this is not entirely applicable because we're talking about the Iframe API, and the only API that we expose to the Iframe is actually an HTML JavaScript-based API. One thing to note is in the new world of mobile devices that may not necessarily support Flash, and iOS is a good example of that. For those of you that are building applications that get mobile views, you probably noticed that this is a very nicely growing area for everybody. Mobile applications are quite hot. So if you invested time in building a Flash-based player around our Chromeless player, the bad news is some platforms will not support it. So all you will get is a black box. So it's a little bit of a bummer. Jeff has a remedy for that, as he will show later in the session. But this is one of the things that you'll run into very quickly if you actually build mobile applications and people that have devices that don't support the Flash technology actually navigate to your page that has a very nicely crafted custom player that you have built that it no longer works. So instead of that, what you can do is use our JavaScript API to the Iframe player. And let's just quickly go through the differences between the AS3 JavaScript player API and the Iframe JavaScript player API. So there's three categories that I would like to describe: the player init, the actual methods that we expose, and the event handling. So player init is quite different between the AS3-based player and the Iframe player. I have a side-by-side example. Hopefully you can see that. But really, on the left-hand side, you see the new JavaScript-based API usage that we exposed. You can load the API library asynchronously and then create instances of yt.player, which is really the player object that allows you to then control the player behavior. When you instantiate the player, you can specify a video ID that you would like to load, as well as any player parameter and event handler. So there's a set of events that we allow application developers to subscribe to. If you would like to do that, you can actually specify the handlers for these events right when you instantiate the player. And then on the right-hand side, this is the old school AS3 JavaScript API initialization using the Swift object to load the Chromeless player library, and the event handling is actually done through DOM event registration, slightly different. That method also works in the Iframe player JavaScript API, but now we have a convenient way of creating the handlers right when the player is instantiated. So when it comes to the actual core player functionality, there's 5 kind of major groups of operations that we expose. So queuing functions that allow you to load video, queue video, playback controls, player settings. You can set the volume of the player, navigate to a specific timestamp in the player. Playback status operations that tell you more about the actual what's happening in the actual video. Playback quality, so you can actually override the selection that we make on behalf of the user when it comes to what is the optimal resolution that we should be trying to stream to the user. So by default, we actually try to detect what is the device capability, what is the size of the window, and then for example, if HD doesn't make sense, we won't be trying to ship HD. But if you want to override it, you can do that programmatically. And then finally, we provide some additional metadata information, such as the duration of the video, the embed code for the video through the API. So comparing these two groups of operations, really everything works pretty much the same. The playback status is the only area where we still have some work to do. So right now, the get video bytes total returns a hard-coded 1,000. And that is hopefully going to change in the future. But other than that, all the other operations should pretty much work the same. So quick note about event handling. As I mentioned previously, the way you initialize the handlers is slightly different, but the actual semantics are very similar. The only note that I wanted to make is that today, if you are counting on the YT player state buffering event or the state to be actually delivered to you, we don't actually generate that yet in HTML5 player. So if the underlying video playback is based on HTML5, you will actually never see that state. Other than that, there are some syntactical differences with respect to event registration. So the AS3 player API relied on the kind of typical DOM-based registration, whereas for the HTML5 player API, what we recommend is using the event registration that is conveniently possible through as a part of the player init. And one note that I wanted to make is that if you would like to kind of play around with the API, for those of you that have used Chrome console, you know all about it. But for those of you that haven't, you can very easily learn more about what these methods are and invoke them and so forth using the console right from the browser window. So it's kind of a quick way to get up to speed on all the functionality that is exposed. And I believe we have actually a session about Chrome DevTools at I/O. So if you haven't caught it, it's a good recording to catch up on later. OK, next I'll hand it off to Jeff. And Jeff will talk about his experience with the API and prove to you that you can, in fact, build very interesting video experiences around YouTube using the new JavaScript API and HTML5 video playback.
Thanks, Jarek. So I'm a member of the YouTube API developer relations team. And part of my job is to help developers use these APIs. So I certainly wanted to familiarize myself with the Iframe Player API. And this example application I'm going to show off is something that I did to get familiar with the API, but also just hopefully something that will help you guys learn, and wanted to share some best practices that I picked up while writing code that hopefully I'll be able to share with you. So this example provides basic YouTube feed player functionality. And what I mean by that, think of it kind of like a playlist player, but instead of only playing back YouTube playlists, you could play back any feed of videos. And it's powered by the YouTube Data API. This is kind of a separate set of RESTful APIs that can be used for interacting with YouTube in a variety of ways. One of the ways is to retrieve feeds of videos. So you could, for instance, plug in a search term and get back a list of all the videos on YouTube that match that search term, or you could get back a list of videos that are uploaded in a given user's account, for instance. So this particular example makes use of some modern web technologies, as you might expect. There's a bit of HTML5 in there. A lot of JavaScript is going on under the hood for interacting with the Iframe Player API. And there's some CSS as well. And hopefully, as I said, this is useful in its own right. Feel free to take a look at the code and use it and adapt it in your own application. But my main purpose was illustrate some iframe player usage best practices. So I just wanted to talk a little bit more detail about the different components that go into this demo. Obviously, on the HTML5 side of things, the video element is quite important. It's going to be used for the supported videos, and this, again, is based on that kind of flow chart that Greg was going over earlier. So assuming a given video that we attempt to play can be played back in the HTML5 video element, it's going to use that. And we're actually using some of the player parameters that Jarek was talking about, in this case specifically, the controls equals 0 player parameter. So this is going to give us a version of the YouTube HTML5 video player that doesn't have the type of, I guess, Chrome is the term that we use for it. It doesn't have the standard play button, doesn't have the seek bar. It just gives us the video playback. And we're going to actually implement the specific playback functionality in HTML5 and CSS and so on. So to that point, we're using SVG, which is scalable vector graphics, and that's just used in a fairly straightforward way just for implementing the pause and play buttons in our example. And we're making use of input type equals range. This is a fairly new input element that can be used for doing scroll controls, more or less. So you'll see it in a little bit when I show you the example, but this is something that allows you to drag and to select a new value for a given control. So Google Chrome currently supports all those features that we're using, which is great because that's what I'm using to demo this. But some browsers offer just a subset. In particular, there's not a lot of support for input type equals range in a wide number of browsers right now. And that'll probably change over time, but at the same time, feel free to adapt this and use something different. There's plenty of open source libraries for doing slider controls that would certainly work as well. As you might imagine, there's quite a bit of JavaScript involved in writing this sort of example. I'm using jQuery just as a matter of personal preference for doing a lot of kind of the heavy lifting. And one of the things that's nice about jQuery in particular is that it simplifies the interaction with the YouTube data API. I'm not going to actually focus too much on the interaction with the YouTube data API, but I definitely recommend looking at the code if you are curious as to how you could write a web application that will do read-only requests to YouTube, get the results back, and display them in some way. So it's actually going to be using JSONP under the hood, which is a method of dynamically inserting a script tag into a page and having that script tag point to a URL basically on our servers, and the server knows to respond back with kind of a wrapper that will invoke a native function in our own JavaScript code with whatever the payload is for the response. So we're basically getting around some of the cross-domain limitations that would normally prevent you from using something like XML HTTP request to directly ask our servers for a response. And jQuery will make that pretty easy. jQuery also just makes a lot of other things easy as well. And everything is JavaScript, more or less. I'll show you, the actual HTML source. It's very short. Most of the important things are done in the JavaScript section, and we'll focus on some specific sections there in a second. And there's CSS, as you might imagine, very basic CSS styling. One thing I did decide to do was just use web fonts, which are part of one of the newer CSS specifications, and I'm using the Google Font API just for pulling down something a little bit flashier, let's say, than the built-in fonts that might be present on a given user's computer. So this is the example. I have this open over here. I want to just quickly load up the uploads feed for the Google Developers YouTube channel. And Google Developers is just a great channel in general for having a variety of different developer content.
Good afternoon.
So this is
Thank you for
playing
coming.
right away.
My name is Max Ross.
Okay, you see, these controls down here. This is SVG, as I mentioned. Right now, because we're paused, the pause button is disabled, the play button is enabled. These are the slider controls using input type equals range. If I do start playback, we should be able to toggle the volume.
I focus primarily on.
And we should also be able to use this to jump to a different portion of the video. Much as you'd imagine, you have the current time listed over here. Just all the basic type of controls that you would normally see in the YouTube player, but implemented completely with our own code. And just to show you, we could also jump to the next video in the feed.
All right, hey there.
You could do that pretty much indefinitely. So just show really quick the source for the HTML. Pretty straightforward. It's just this page of code. Most of logic, as I said, is done in JavaScript. So I wanted to jump to that and show you just a little bit of the JavaScript. And particularly, I wanted to focus on the JavaScript that's used to handle player events. And this is kind of what I found the most difficult to get correct. And when I've worked with developers in general and just spoken to folks, I think this is the hardest thing to kind of wrap your head around, how to respond to the proper YouTube player events. And it's really key if you're writing a custom player experience to get this right. Otherwise, you end up having UI elements that are disabled when they actually need to be enabled, or just not taking into account the fact that an error has happened and things like that. So there are kind of three main categories of events that are handled via the YouTube Iframe API. There's the onReady event, and this is fired when the player API is initially available. So if you wanted to do something as soon as the player API is available, and as Jarek mentioned before, the Iframe API right now is the way we recommend loading it is asynchronously. So it doesn't necessarily, it actually will not be available whenever your DOM is fully available. It's going to be at some point afterwards. And if you want to put in some code that gets fired only when everything is fully ready, you would put it in your onReady handler. The onError handler, as the name suggests, is something that we get fired whenever there's any sort of playback error. For instance, if a video is not playable on your particular device for any number of reasons, that will get fired. And it's pretty important to put in some code for handling that. It might be as simple as moving to the next video if you happen to have a list of videos, or displaying some sort of error to the user. But it definitely helps the user experience if you were to put in some code to handle that. And the third category of events is on state change. You can kind of think of it as a catch-all that has a bunch of sub-events for the different changes in the YouTube player state. And I wanted to focus most of my time talking about that. So kind of 5 main events: ended, playing, pause, buffering, and queued. As Jarek mentioned, the buffering event won't be fired for HTML5 player now, but those other events are all relevant. And in general, my recommendation is just not to make assumptions about the global state of the player or what triggered the event in your event handler. And one example of where somebody could go wrong is they see that the YT player state playing event was fired in their event state change handler, and they figure, okay, well, if that event was fired, it must be because somebody clicked on the play button. But there's actually a number of other ways that playback could start for a given video. The user might have clicked on the actual YouTube video itself, which is something that will trigger playback. Or, as Greg was illustrating before, there are ways to use the keyboard controls for, tabbing into a video and starting playback. So if you have any specific assumptions that are built around the fact, okay, somebody must have clicked on the play button, they might be wrong in your play handler. So I would recommend explicitly, especially when you're changing the state of other UI elements in response to events, I would recommend to explicitly set the state each time through in your event change handlers to whatever the appropriate value you know it should be for that event, rather than just like toggling a given element. And I think that leads to a much better user experience. So I wanted to get into some of the code that was relevant to that point, and just a few helper functions here for enabling and disabling a list of different elements given their element names, element IDs rather, and just a helper method for setting up the task that fires in the background, basically that updates the current time in what we saw in the lower left corner of the player, the current playback time. So we have something that will set that up for us, because we're going to need to clear that in certain circumstances and then reestablish it later. So this is just some snippets of code. We, for instance, would handle the queued state event, and this is what gets fired when the player is the video is loaded into the player, but playback hasn't actually begun yet. And in that scenario, as you might expect, you think, okay, what controls do I want to be enabled in that case? And you want the play button to be enabled. And what controls just don't make sense to have enabled? And pause, volume, and seek, they're not going to be able to do anything when you're in that queued state. So you want to explicitly change those values to those states each time you get into the queued state. And something very similar for thinking about the pause state, except there's going to be a different set of things that you'd want to have enabled. So you want the play button enabled, you want the volume controls to still be enabled, because you could still change the volume of the video, even though it's not playing. And you'd still like the person to be able to jump to a different point in the video, so you want the seek bar to still be enabled. But again, you don't want the pause button to be enabled, because it certainly doesn't make sense. And we're also going to clear that background timeout that would be fired to update the player time, because if the video is paused, we know that the time is not going to be incrementing at all. And playing is, in some respects, the opposite. We want to enable the pause button, the volume button, the seek button. We want to recreate that interval. We want to set the volume and the duration values to whatever they are by reading that via the API call. And this might be overriding the existing values. There might already be a value for the duration there, or the volume might already be equal to whatever the current volume is. But it's really not going to hurt anything to set that again. I might be wasting a couple of CPU cycles, but I found it just simplifies things greatly if you don't make any assumptions about what's already there in the state and you explicitly set it. And finally, ended very similar to what we've seen before. One thing I wanted to point out, excuse me, one thing I wanted to point out is that it really makes a difference, I found, to explicitly set whatever the current time is in the playback, and that's the value that you'd see over here. This is the current time, this is the duration. Once the video is over, you want to make sure that that current time is set to the duration of the video. I'm sure folks have had the experience where you reach the end of the video, and maybe it's because the video is not, it has like a fractional second in its duration, and there's some rounding involved, and it says the video is 4 minutes, but you're at the display says 3 minutes and 59 seconds, and you're like, well, what's in that secret one last second of the video? And obviously there's nothing there, but it just leads to a better user experience to explicitly set that. So that's my recommendation for handling the ended state. And yeah, that's kind of an overview of some of the JavaScript in the example. Definitely feel free to take a look and explore some more. I wanted to remind folks that we have those, we have those hashtags, IO 2011 and YouTube for this session. And if you have any feedback, you could go to that URL as well. And we wanted to take any questions you guys might have either about the Iframe Player API or YouTube topics in general, and hopefully we'll have some answers for you.
Before we jump into the questions, I actually want to promote, we've got this awesome after party coming up. And so YouTube's one of the main sponsors for it. It's at Thirsty Bear. You can come grab tickets for us. And one thing that's really important is there's a QR code on the back. If you scan it and register ahead of time, you'll get to skip the line to go in. So hopefully you'll join us tonight for that.
Hi. Quick question for you. I've used the iframe player a little bit. Is there a way to, whether it's Flash or HTML5, that's being exposed on the client side, is there a way to set the window mode to transparent or interact with the CSS of the HTML5 video player?
Yeah, so you can add W mode as one of the arguments in the URL, and so that way you'll interact with Flash, and then you can just interact with the iframe with CSS like you normally would for if it's the HTML5 player.
Hey, so with the OEmbed endpoint, I know that you can add that parameter to get the iframe code returned. Are there plans to start returning the iframe code by default on the OEmbed endpoint, or not in the foreseeable future?
Yeah, we actually recently made a slight change to the OEmbed endpoint that ended up breaking a lot of folks, and that was just changing one character in the URL. So I think I personally would advocate that we don't make too many changes to our defaults and continue to allow folks to explicitly request things in the hopes of not breaking too many existing implementations. That's my personal preference. I'm not the one actually responsible for the service, but that's what I'm hoping.
One issue that we've seen is, people build platforms that don't allow iframes, and then so the iframe actually has to be whitelisted. And that has been kind of #1 source of pain as we were rolling it out, working with a lot of the, say blogging platforms provider, sites and so forth, so that they will actually allow this iframe. And we've made a lot of progress, but there's a lot more work to do. Yeah.
Hey guys, I had a question about the accuracy of the skip to and skip ahead function. I noticed during the caption talk that was in here earlier that there was fractional seconds involved for the start time and the end time for a given piece of text. My question is, are there plans to make it more accurate as far as a skip ahead, skip back, just to make navigational control a little bit easier, or to be more accurate with any sort of external navigation that we can develop?
So one of the nice things about HTML5 is we actually don't have that issue. So with Flash, you worried about keyframes and having to jump to a keyframe. HTML5, just the standard, just goes to the time that you specified. So you'll have that accuracy that you want.
Can you do like fractional seconds or anything like that?
I haven't tried it. I don't know.
Cool, thanks.
Hi guys. The API documentation says that the iframe player API is currently not ready for mission or business critical applications. I was wondering what the time frame for that to be removed is, that restriction.
Yeah, I don't think we have an exact time frame. This question comes up a lot. I think just the important thing to realize that it is still a work in development, and in the course of me writing this demo application, I know I filed about half a dozen bugs against Greg to resolve. So I think it's not there yet, and hopefully that does not stop folks from using it in their either non-mission critical environments or just trying to develop against it in parallel to whatever their existing thing is. And definitely file bugs. Let us know in the Google group in particular. I think that's the best way of getting in touch with us. And Greg is super responsive about getting things fixed. And as we get to a point, I think, where there are fewer and fewer reports of things going wrong, we'll have a greater confidence in taking off that label and be able to say it should be as supported as our AS3 embed.
Okay, thank you.
What's the timeline on getting iOS support for the auto playing? I know that's an Apple issue and not an iframe issue.
Yeah.
But when you've talked to the team, have they given you a sense of why they've disabled auto playing on the kind of iframe player? And is there any ETA for getting that fixed? Do you see a resolution happening?
So we work very closely with Apple. I mean, they're obviously driving a lot of our playbacks. And actually, if you look at the documentation closely for the video playback, it states that for 3G environments, the user interaction is required. And I personally kind of buy that.
Right.
But then on Wi-Fi, one maybe should be a little more liberal. And in fact, this is what we've been trying to see if the team at Apple could add that. But I don't have an ETA. But we have filed an enhancement request with them, and we work very closely. They're a good partner.
Gotcha, but they seem favorable to the idea that auto-playing in theory would make sense on Wi-Fi connection.
I wouldn't go as far as saying that they are favorable. But if you kind of look at the user documentation from our perspective, there's a discrepancy in behavior, or the Wi-Fi behavior is unspecified. So if it is unspecified, perhaps we could make it work just like what we described. I think that would be probably the best solution for application developers and carriers and everybody else involved. Yeah.
Sure. I guess on the YouTube app that's native to the device, as I understand it, Apple built that, not YouTube. Is there some workaround that you can envision that if you're building a native iOS app, you'd be able to support the auto playback? Or is there kind of no workaround?
So for native iOS apps that incorporate YouTube video playback, there's really 3 approaches that you can take for video embedding. One is you can kick off the YouTube player, right? So that's one. The other one is you can use the existing Flash embed. And what iOS does is recognizes, oh, this is a YouTube embed, and then uses a Safari plugin in order to play back the video. And this is where this approach falls apart if you build your own Flash player and no longer can iOS recognize the signature, and then you get a black box. And the third approach is the iframe embed. So if you build a native iOS application, you can actually use UI WebView and embed the AS3 embed or the iframe embed, and then iOS will recognize it. In one case, it uses the Safari plugin. In the other case, it uses HTML5 video playback. The HTML5 video playback has the advantage of actually having an API around it. So I know more and more application developers are using the iframe API for iOS applications because it is the only game in town. So even though technically we're saying that, hey, this is not mission critical, but the argument we're making, it's still better than nothing, So you can actually do something.
Yeah.
So that's kind of the story that we have. But I think all of them suffer from the same fundamental limitation when it comes to autoplay.
Yeah, I've seen some hacky solutions where you can fire a touch event, and you kind of crawl the player, and then find out what the play button is, and then you send a touch event, which apparently isn't allowed by the documentation. But they've let apps kind of do it. Is there any other solution beyond that works, or is that kind of the only thing for autoplay you've seen?
Yeah, so we don't have anything that we support right now for that. Yeah.
Good, thanks.
Hey, so I have a habit of putting Linux on old laptops, and then at previous companies, I was always trying to get real movies playing on old hardware. Is the performance of HTML5 video so much better than Flash that it really makes it possible to watch movies on old hardware?
It's sort of a little bit tricky. So when the encodings are in H.264, the performance is generally a little bit better in HTML5, although I don't have any numbers to give you. WebM, I usually don't see performance being as good because you don't have a specialized chip for it. But they're making a lot of improvements there. But also a lot of what we've been doing in WebM, it's got less bytes for the same amount of quality. And so it's a better. We think that it's a better encoding. But yeah, we're still sort of struggling on making sure that the performance of the CPU is going to be equal or better. Cool.
Okay, doesn't look like there are any more questions, so thanks you guys for coming.
Thank you.